So in this video, we're going to talk about trigonometric substitution, okay? And in this video, I'm not going to do the actual integrations themselves. I just want to focus on what will we substitute for x, okay? And I'm going to show you how we get about that. So the idea is that we have three cases. We have the square root of a squared plus x squared, which a is just some number. We have the other, we have another term where we have a squared minus x squared. Again, a is just some constant. And then we have the form x squared minus a squared, okay? Now these are the three forms that trigonometric substitution will come into play. And essentially we got to remember some identities here, okay? So essentially, some number squared minus a squared, right? So x squared minus a squared. Well, this happens to be secant squared, and I'm just going to use theta as the variable. It's just to not get you guys confused. So this is secant squared of theta minus 1, and that is equal to, we know that is equal to tangent squared of theta. So this is the idea that maps to this, okay? This is the identity that maps to this form here. Now, remember, this is 1 squared, okay? Which is a squared. Well, 1 squared is just 1, so that's why I just put 1 there. Now the form, the square root of a squared minus x squared, this happens to be 1 minus cosine squared of theta, and that is equal to sine squared of theta. Now, I just want to make a distinction here. This could also be 1 minus sine squared of theta, which is equal to cosine squared of theta. So there's two ways for this one. So this will be 1 minus sine squared of theta, and that is equal to cosine squared of theta, okay? Now the identity that maps to this one is, we know, is tangent. And we say tangent squared of theta plus 1. Well, that happens to be secant squared of theta. Now notice I wrote it a little bit different. Well, yeah, because my x in this case would be x squared, tangent squared, but again, it doesn't matter. Since it's addition, I could switch it either way. So I could say 1 plus tangent squared of theta, that is equal to secant squared of theta, okay? So these are the three identities that we need to know, okay? And so with that being said, let's look at some practice. So let's look at some integration and see what will be our substitution. So what if we have the integral of dx over square root of 9x squared minus 4, okay? Well, again, notice that this is trigonometric substitution. Well, what would we substitute for x? Well, to me, it looks as if I have x squared minus some sort of a squared, which is a number. And so if I look at this, well, what is the identity that maps to this form? Well, it so happens to be that 1 minus cosine squared of theta is equal to sine squared of theta, where I have some sort of, or either way, it could be in this case, it would be secant squared, okay? Because we have some number x squared, we have some variable x squared minus a number. We have x squared minus a squared, which is a number. And so the identity that maps to this is actually secant. So we could use secant squared of theta minus 1, and that is equal to tangent squared of theta, okay? Now here's the idea. We always want to look for this last term here. We always want to look for this last term here to see if it is 0. And the reason being is that, well, not 0, is if it's 1. And the reason being is that we got to change some numbers here. So whatever this number is, the last number is whatever I'm going to put in front of all these terms here, okay? And you're going to see the pattern. So because I have a 4 here, this has to be 4. This has to be 4. And this has to be 4. Okay? Because I don't have 1. And so when I look at this, well, what maps to x squared? Well, remember, it's secant squared, okay? So this whole term now will actually map to my 9x squared, okay? And so if I look at this, now my 9x squared, I'm going to set them equal to each other. So 9x squared now becomes equal to 4 secant squared of theta. And so if I divide by 9, because I want to figure out what will I substitute in for x, well, x squared now becomes 4 over 9 secant squared of theta. And then if I take the square root, x becomes, well, square root of 4 is just 2, square root of 9 is 3, and the square is secant squared of theta. Well, those will cancel out, so that will just give me secant of theta. And this will be what I'll substitute in for x. Okay, let's look at another one. Okay, let's look at another one. So, okay, so what if we have the integral of dx over 9 minus x squared? Okay, how would we actually integrate this? Well, to me, it looks as if this is cosine. We have a number squared minus a variable. Okay, so we have a number squared minus a variable, okay, which is x squared. And so this looks like to me it's in the form 1 minus cosine squared. And so if I look at this, or I could use 1 minus sine squared, doesn't matter. I'm going to use 1 minus cosine squared. So this becomes 1 minus cosine squared of theta. And that is equal to sine squared of theta. Now look, this number here is not 1. Okay, this number here is actually 9. And so I'm going to replace 9 in front of all my terms in the identity. So this becomes 9 and that becomes 9. Now remember, we have some number h squared minus x squared, which happens to be cosine squared of theta. So in fact, 9 cosine squared of theta is what maps to x squared. And so if I look at this, well, x squared is equal to 9 cosine squared of theta. So I got to set them equal to each other, just as I did in the first problem. And so what do I figure out for x? Well, I take the square root of that. So x is going to actually be equal to 3 cosine of theta. And this is actually what I'll actually substitute in for my x value of the trig substitution. Okay. Now, what about this one? What if we're given an integral where we have x squared over the square root of 1 minus x squared dx? Okay. What will we substitute in for x? Well, to me, it looks as if we have the form 1 minus cosine squared of theta. Okay, so a squared minus x squared is equal to sine squared of theta. So I'm going to write my identity out. So this is 1 minus cosine squared of theta. And that is equal to sine squared of theta. Now look, this term happens to be 1. Okay, and so because this term is 1, we don't need to change anything. Okay, we don't need to change anything. This last term here is 1. And so in fact, x squared is just going to map to cosine squared of theta. Okay, and so if I take the square root on both sides, x is actually going to be cosine of theta. So this is what I'm going to substitute in for x. So again, hopefully you could see the pattern here. It's not anything difficult. Now, what about this one? Okay, what if we're given the integral of... So what if we're given the integral of the square root of x minus 2 squared plus 25 dx, okay? Well, to me, it looks as if this is an integration problem, okay? And so again, trig substitution problem, okay? And so again, what is my form? This is in the form some number x squared plus a squared. Well, we know that happens to be tangent squared, okay? We know that happens to be tangent because we know tangent squared of theta plus 1, or a squared plus x squared is equal to, we're going to use our tangents. So a squared plus x squared is in the form we're going to use a tangent squared plus 1. Again, x squared plus a squared doesn't matter. A squared plus x squared or x squared plus a squared, because it's addition, the sign, the form, wherever they are, it doesn't matter. And so if I look at this, this becomes tangent squared of theta plus 1, and that is equal to secant squared of theta. Okay. Now, again, look at my last term here. That's 25. It's not 1. And so we got to replace 25 in front of all this, in front of everything in the actual identity. Okay. And so now we know that 25x squared, or 25 tangent squared of theta, maps to x minus 2 squared. Okay. And so we know we could set them equal now. So this becomes x minus 2 squared. And we know that is equal to 25 tangent squared of theta. Okay. Now we need to solve for x. Okay. And so in fact, if I take the square root on both sides, well, the 2 disappears. So this becomes x minus 2 And that is equal to, well, the square root of 25 is 5. Square root of tangent squared is just tangent. So that'd be 5 tangent of theta. And again, we're solving for x because we gotta figure out what we're gonna solve, plug in for x. So this becomes x is equal to 5 tangent of theta plus 2. So the only thing I did was just move my tangent, my 2 over. Okay, and this will actually be what I'll substitute in for x. So what's the idea I want you to get away from this video? You need to know the identities and you need to know what form corresponds to them. Okay, once you know that, then you look at the form. If your last number is not 1, you're going to replace the whole identity with the number that constant number by itself. Okay, and so essentially you just map the x squared number to the squared term in your identity. Okay, and that's the general idea. I did like four problems, I think, and so you should see the pattern. If you don't get it, look at the video again. You should see the pattern.